All right, I'll back up a couple seconds because OBS died. But so I was really just talking about the availability of all the different types of Docker images that you could run into, and yeah, you can run an entire Linux stack if that's what you want to do. This gives you the ability to, like a VM but quicker, log into the thing, issue some commands, maybe blow the whole entire thing up. But again, it's not a big deal. You tear down the container, you rebuild it back up. The benefit of containers over VMs is that you don't have to allocate hardware to a container. It runs like any other software on your system. Think of when you launch Chrome. There is a joke that you dedicate an entire 8 gigs of RAM to Chrome, but that's not really how it works in reality. Chrome will use what it needs. It communicates with the system to not take too much. If you're running out of RAM, you start using swap space, but intelligently. With a VM, the VM just assumes it has 2 gigs. So it's going to use all 2 gigs, regardless of whether that's forcing the host system to use swap or anything like that, right? It's a bit oblivious. So containers have an advantage in that they have more direct access to the hardware and can intelligently use that hardware much better. So anyhow, Docker tends to run best on Linux, but it will run on Mac and Windows. I think Windows has a solution called Windows Subsystem for Linux, which is basically just running Linux inside of Windows. I think Windows has finally given up the ghost as far as fighting against Linux. It has just said, "Fine, you win. We'll just integrate you into Windows." So yeah, I think that really stops the flow of people from exiting Windows altogether and just using more and more Linux. So this is a way you can tie them together and get people to continue to use Windows. Anyhow, so all the orchestration stuff that we were talking about before does work, but there's another layer of that. So as I mentioned before, Ansible, Chef Puppet, those will work for configuration management. However, there's another layer to that. Docker Swarm and Kubernetes will allow you to manage multiple containers. So think about it like this. You've got 5 servers in 5 different locations around the world. You want all of those servers to run the same services. So say you run one major storefront, a website that people can go in and put stuff into their cart, check out with PayPal, whatever. They do that whole entire thing. Docker Swarm and Kubernetes, who are competing, by the way, they are solutions that allow you to run one container, but spread it around those 5 different data centers or 5 different sets of servers, so that if, let's say, you have a fire in one of the buildings and all of those servers go down, maybe your servers don't get burnt up, but the internet connection goes down or something like that. So you're kind of stuck at that data center. That data center needs to come back up, obviously, but it can't come up this instant. The job of Docker Swarm and Kubernetes is to move the containers from where they were running to some of the servers that are either less overloaded or just not busy at all. So it's an orchestration software that allows you to really kind of get to this point where you're very resilient to loss like that. So VMs can do that, though it's a lot slower. So you've got to really be on your game, or you really have to pay a lot of money to VMware, Hyper-V, to I guess Microsoft, not Hyper-V, but VMware or Microsoft to get a lot of those that feature set. So anyway, these kinds of solutions right here are really why containers have really taken off, because as far as a data center goes, you don't have to pay for Linux at all, unless you're buying not license, you're buying support for it, like Red Hat and Ubuntu offer. But on top of that free Linux stack, you can run Docker Swarm or Kubernetes for free to run containers that you pay no money for to really kind of just build your entire infrastructure for $0. Obviously, you got to pay for the hardware, but if you're running your own hardware and you've already invested in that, you don't have to spend more money. But you can if you need support or if you need support contracts, things like that. That's really where the money tends to happen in open source software, right? So I just said it's free, it's free, it's free, it's free, but yeah, there's money somewhere, and that's in support. When you can't handle it or you don't have time to deal with it or something like that, you can pay the Red Hat engineers to come in and save your bacon, so you can concentrate on other stuff. Anyway, cloud and virtualization, those are the basic ideas of all of that stuff. So we'll get into booting. So you got to run a Linux VM or a Linux instance somehow, and this is kind of the basics of what happens when you press the power button. So it doesn't matter how you boot Linux, whether that's on actual hardware. So you've got a server and you've installed CentOS on it, or Red Hat Linux on it, or Ubuntu on it, or you've installed it in a VM like we've done in the class. Doesn't matter how you do it; they all boot the same. You have a few different features that you can use during boot. Even VMs. VMs can take advantage of PXE, which is a way to boot your system where the VM or the server or whatever it may be looks to a network location. Usually that's an NFS share, a network file system share, or some other network accessible protocol that PXE or that your machine will be pointed to, so that you can find, say, the disk that you need to boot from, or whatever the deal may be. One of the cool things about this is, in a situation like this, you don't even have to have a hard disk. We have been running, I think, in the IT industry for a very, very long time, this thing called thin clients that may have some storage locally, but really don't have to. You can run into situations a lot of times where you just need a good chunk of RAM and a monitor hooked up to a box that really kind of hosts a glorified USB hub that you plug in a USB mouse and keyboard, maybe a flash drive or something like that into, and Windows or a Linux desktop is presented to you, and you click around, and to you it's no different. It looks right. It's a desktop. But everything was loaded off of the network using a protocol called PXE during boot. So PXE is used. DHCP has to play a role here. So if you don't know, DHCP is the way that we automatically assign IP addresses in a network. So you get a automatic address using the PXE protocol so that you can access the TFTP server, so the Trivial File Transfer Protocol server. Really, that's just a way to get at files very easily. And this is where you will load your operating system. That might be pointing to an NFS share. It really may just be some teeny tiny box that houses an ISO or houses some kind of virtual hard disk that you can boot off of. Anyway, there's a new iteration of PXE called iPXE or iPXE that allows you to use FTP and HTTP servers. HTTP tends to be, widely used. So most folks have some kind of web server wherever they are, or if you're familiar with Docker, you can spin one up very quickly. Anyway, so outside of that, most machines will probably boot from a local hard disk, not from PXE, which is the way that you've set up your VMs. Anyway, regardless of how you boot, there is a bootloader of some kind. So the idea is that you can't just look at a VM and tell it, all right, boot. It's got to do stuff. And that stuff is handled by the bootloader. So let's look at a VM, for instance. Wait, right here. Let's see. Let's bring up Ubuntu. That should come up quick enough. So right. Oh, you know what? It didn't stop at the bootloader. Ubuntu does not give you the time to see the bootloader. It just automatically boots. It sees it's the only operating system, so it automatically boots. So with Ubuntu, you do have to catch it with escape. There we go. So hit escape a couple times right when you see the Ubuntu, or I'm sorry, the VirtualBox logo, and you'll catch it here. This is the bootloader. So these are all the different options that the bootloader will have you, will give you. Choosing the first will boot the only operating system on the disk. There are some additional options where you can roll back to older kernels or something like that. So let's say you've run updates, you have the newest kernel which adds security fixes, things like that, but it broke your system, you can no longer boot. You'll come to advanced options here and choose one of the older kernels, or you can get to a rescue mode where you can mark a separate kernel as the default one. Anyway, what you'll do after that is delete the new kernel once you boot into the operating system. A lot of times you'll run into situations where your VM or your entire host machine will hang. This is where this memory test will come in handy. You can run a memory test to find out whether or not your RAM is good. All of it. Every single nook and cranny of your RAM. Is it good? And if it is not, the unfortunate truth about that is that you got to throw that stick away. Otherwise, you'll run into way more issues than otherwise. Memory issues tend to cause the lion's share of Windows blue screens. So if you are in a situation where you're blue screening over and over and over again, it might be memory. It would be a good idea to run a memory test to just rule that out. But the other half are weird, wonky driver issues in Windows. Linux does not have blue screens. They have what is called a kernel panic. But it's the same basic idea. The system has an unrecoverable error. It will give you some information about what happened, and then it will just reboot. Best case scenario, it will reboot and boot back up. Otherwise, you might run into some weird issues. Anyway, so I'm going to keep this here. We'll come back to this in just a little bit. Anyway, if you noticed, you can see GNU Grub version 2.02. And you can see the big heading down here, Grub 2. That will come in handy. So anyway, Lilo, SysLinux, and Loadlin. So Lilo was the most popular alternative to Grub, but it has mostly died out. It still exists. You can still install it. You can replace Grub with it. It will work, but it is less configurable than Grub, so it has fallen out of popularity. However, you can still use it if you want. SysLinux tends to be the operating system that you find, or I'm sorry, the bootloader that you find on like these live USBs that we use. So one of the cool things about Linux is that you can flash the ISO to a flash drive, plug it into a system, reboot the system, and choose that flash drive as the boot device, and it'll drop you into a full-on Linux environment where you can do things like fixing Windows boot records or pulling off files. The most important thing that I do with a Linux operating system on a flash drive is load that up on people's laptops that have died. So say Windows won't boot anymore or something like that. Likely, the disk is still working. Just something happened with Windows that prevents it from booting up or something like that. So before we do a Windows reinstall, I load up into Linux and copy off all their files so that there's a backup. And then we do a Windows reinstall, and then I plop the files back on. But the fact that SysLinux exists as a bootloader enables us to do this live USB thing where you can really just do whatever you want to in an environment. This also does have a dark side, right? I mean, if you walk into an enterprise and the folks that manage all these systems don't lock the bootloader or lock the BIOS so that you cannot choose another boot device. You can run Linux on corporate machines as well, and that may give a malicious actor a foothold in your network that is less identifiable than some of the operating systems that they run in their system already. So.
My laptop that I had to replace, and then I had to get
So the cool thing about using Linux like that is that you don't have to install it. You just boot from the flash drive and you get a what's called a live environment. But you would still need another disk. If there's more than one disk in the system, you could use the secondary disk. But yeah, I mean, I just carry around a 1 terabyte, 2 terabyte external drive and use that to back stuff up to. But you would still need a second disk and a flash drive to have Linux. But the real advantage there is that you don't have to install it. So plug it in, 5 minutes later, you've got an entire system that you can use to do backups or whatever you need to do with. Real interesting stuff. All right. Then you have Loadlin, which is just another competitor. You tend to use Loadlin if you're trying to not load Linux, but this is just a bootloader that can understand the other types of boot. But here's the thing. Outside of SysLinux, Grub can do everything that Lilo and Loadlin can do. So there's really no need for the other two anymore, and that shows in every major Linux operating system uses Grub, not Lilo or Loadlin. Now, most of those major operating systems will use SysLinux on their live USBs or their live ISOs, but outside of that, it's Grub. Grub. So that's what we'll focus on. Anyway, so Grub stands for not a Grub, but Grand Unified Boot Loader. And of course, 2 is version 2. As you can see up here, version 2. So it's the most common bootloader. It can boot from either the old legacy BIOS style booting. It can boot to the new style UEFI booting or EFI boot. And it can also do everything in between using the compatibility mode, CS something or another. I forget what it is. I have to go look at a BIOS. But yeah, there's a compatibility mode that allows you to boot UEFI off of legacy style bootloaders. Anyway, so the way that this works is you post. So you do the normal, it initializes the disks. You see that splash screen says MSI or Dell or Lenovo or Asus or something like that. Or you just get like a scrolling white text if you've turned off the splash screen. But after the initial post, it is handed off to the initial bootloader, the first stage bootloader. And this lives in either, if you're on legacy, master boot record or the EFI partition. So master boot record lives on the front of the disk. There is a small sliver of a partition that lives on your disk that contains the master boot record, which basically says, hey, I know the thing that you want to load. It's over there. It's pretty much all this does. Same with the EFI partition, though the partition is a real one now, not kind of a hidden tiny one. EFI partitions tend to be small, like less than a gig. I guess they can be whatever size you want them to be, really. Especially in Linux, you can tell the system, hey, use a partition this size. But most of the time, these EFI partitions are about 256 megs or 512 megs. Not big. It won't make an impact on or a big impact on the total system storage that you have. But either way, both of these things work similarly in that they are the first stage bootloader. They during post, it will scan the disks. Your system, your motherboard, will scan the disks for either of these if you've allowed it to. And once it finds one, it will load up, or it will use the instructions that are found here to load the second stage bootloader, which in our case, in Linux's case, is Grub. So information about Grub is stored here. And then second step is load Grub. Now, the real important thing about Grub is that it knows where the kernel is. And it knows where everything else is. The limitation here, the reason why you have to have first and second stage is the limitation here is that you don't have a lot of space a lot of times in these situations, in the master boot record or in the EFI partition. You don't want to clutter that up with all of the stuff. It might fill up, and if it fills up and you make changes, those changes are lost, and you may end up with a corrupt master boot record or a corrupt configuration in EFI. So you want to break it up. This has basic information about where Grub lives. Grub will handle the rest. So that's why it's so important, right? You have a memory test. I mean, we literally load the memory test inside of, or right next to Grub. So anyway, you'll find the main configuration right here. You can go into your system, and it may be either boot Grub or boot Grub 2. Let me see. I'll load Ubuntu, and we'll find that, and we'll see what it looks like. Right. If you're installing new drivers that Grub needs to know about to make it available, well, let's say that Grub needs this driver to boot. Any of those drivers or any of those modules will exist right in this directory. And then otherwise, if you have a system that has a broken Grub or broken bootloader, you can reinstall it on the disk. So in our case, this would be SDA instead of SD asterisk. So you can do grub2-install space /dev/SDA in our case, and that will reinstall Grub. So if you run into a situation where you know Grub is broken, or you accidentally broke Grub yourself, before you reboot, run that command, and Grub will reinstate itself. So there are a few other things that we'll learn about Grub, but we will learn them as we run to the scenarios of all of that kind of stuff. So more to come, but this will really cap it off for this week. I'm going to show you a couple other things about what you do when you run into that situation where you're in that Grub command line. But those are the broad strokes. All right. So the quiz comes from the notes, and it's also going to come from the demonstrations I show you here. Oh, okay. So I'm going to go ahead and use the Kali Ova. Oops, wrong thing. What I wanted to do real quick was show you, what was it? It was Cat. Oh, no, I'm sorry. It was Etsy. Where was it? Oh, boot. Yeah, so in Ubuntu, it's going to be Grub. I think in CentOS, it's Grub 2. But from here, you can find Grub CFG. And let's take a look at it. And this is quite literally a script. This will show you kind of the high-level view, essentially. Here are the modules I was talking about. Those modules right here, that live right here. This gets automatically updated when you do a Grub update or something like that. Again, you don't need to know this stuff just yet, but that stuff is coming. So anyway, these are basically all of the commands that are run in the Grub command line. I will show you the Grub command line here in just a minute, but I mean, do you see that? There's a lot. Understanding all the things Grub does takes a long time and a lot of trial and error. Okay, so let's dive in here. So the first lab that you're going to run into is installing via an OVA. So you saw me do that earlier in the video, which was quite literally download the OVA, double-click the OVA, import the OVA, and you're done. That really is all there is to it. Let me see. Oh. Well. Now I know why OBS might have crashed earlier. I've got a lot of VMs going. Okay, anyway. So the OVA that I installed earlier, quite literally, double-clicked on it, right? That was it. Import it. That was all you needed to do. Here, I'm going to do this. I'm going to power this one off too. All right. Well, I'm going to let that finish up. Otherwise, if I power it off now, something might be incomplete and not boot for me. And I don't want to have to reinstall Ubuntu, so I'm going to let that do its thing. Anyway, so we'll bring this up here in just a minute once... well, it's not too bad, I guess. 2 gigs, 2 gigs. Should I chance it? Oh, okay, cool. Didn't take long. All right, so let's bring up Kali. And really all I need you to do is go find... Oh, no. Oh, okay. You might actually run into this as well. This is pretty common if you did not go out and install the VirtualBox extension pack. So to fix that, quite a lot of you will probably run into this. To fix this, I think it's under ports, USB. Just disable the USB controller. This way it won't complain about the extension pack. There we go. So the extension pack is basically allowing a few cool new features that are licensed, though. It cannot be added on to a VM without accepting a license, essentially. And when you install that extension pack, you accept that license. It's, you know, it's one of those scroll things that nobody ever reads. Yeah, those. All right. So to log in, notice down in the description, it tells you what to log in with. Username Kali, password Kali. These are the most secure username and passwords ever. Now, for those of you that know what Kali is, yeah, don't get too excited. We're not going to dive too far into that. This isn't really a security class, though. If you're interested in this kind of stuff, please let me know. We can talk about it outside of these lectures or whatever. One of the things that I miss about teaching security classes is breaking stuff using Kali. Anyhow, what I really wanted you to do is, while it's importing, like I said, it takes 3 to 10 minutes. Take a screenshot while you do that, right? Take a screenshot while the appliance is importing. I don't know why I have that twice, but just take one. You only need one here. Once it's imported, let me see. Yeah, I mentioned here you either need to disable USB, as I showed you, or go to virtualbox.org and install the VirtualBox extension pack. Either will fix that problem that I had when I first booted up. Log in with the username. This is incorrect. Root and tour. I will go in and fix that. But hey, guess what? It's in the video now. So it's Kali and Kali. And then take a screenshot. So I'm really just looking, you know, is Kali booted? Take a screenshot of that right there, that desktop. And that will show me that you've got Kali installed. And then really what I want you to do is find the kernel. And you do that with this command. uname-r. You can do uname by itself, or you can do uname-a to show you all the crazy cool information about this particular instance. You can see its kernel, which was isolated up here, right? You can see that it's Linux. Oh, sorry, Linux. You can see its host name. You can see the kernel. You can see what it was built off of, which is Debian's kernel, modified for Kali. And Debian is one of those grandfather distributions. Ubuntu is a descendant of Debian. So is Kali. You can see the last date and time it was stamped, and what type of system it is. A 64-bit or a x86 instruction, 64-bit GNU Linux operating system. So I really just need you to do this, and I just wanted to show you. There's more to it than just that. But that's your kernel. This is the version number. You don't need the Kali 1-AMD64-bit. This is the kernel version. So just the number part. And that will come in handy. Knowing the number part will come in handy here in a little bit when we get into Grub and find out the other kernel versions as well. All right. Okay, well, I mean, that's quite literally it. Most of this lab is about importing an OVA to see how easy that is. Let me just show you the opposite side of that. So I'm going to shut this down. The opposite side of that is creating an OVA. I'm not having you guys do a lab on that or anything like that, but it's very, very simple to do. So in Windows, it'll likely be right up here, but in Mac, obviously, it's weird. So you will export appliance. So highlight the one you want. Well, actually, it doesn't even matter. You don't have to highlight anything. You export appliance, and then you choose the one that you want here. Whatever you highlight prior will be highlighted. Highlighted? I don't know. Right here when you start. But it doesn't matter. You can choose one or more. You can do multiple if you'd like. But let's just do one. Continue. And you can see you're about to create an OVA file. And this name is generated from the whatever you named it in VirtualBox. So if I named it Ubuntu server number 5, that's the file name that would be created right here. So the cool thing about this OVF format or OVF is that you are able to move these from VirtualBox to VMware and back again. So it transcends the idea of a locked-in hypervisor. If you create it on VirtualBox, no big deal. You can move it to VMware if you want. And then once you hit continue, I want to say, yeah, okay. And then you can add some detail to it. This is where Kali added all of that information, kali.org and the login information and all of that. Once you hit export, depending on how big the VM is, it will take that long, and it will just pop out that OVA file that you can use for moving from one place to another. So adding an OVA to your system, creating an OVA off of an already created VM, very, very simple to do. And then do a few things, right? Find out what the kernel is. That kind of stays in line with what we're already doing. So in the second lab, in all three, OpenSUSE, CentOS, and Ubuntu, I want you to hop into the bootloader. Basically, you can stop the boot process at the bootloader stage, at that stage 2, so that you can add in additional options if you need to do something different on this boot, or you can really just gather some information, and that's really what we're going to focus on, gathering information. So let's fire up OpenSUSE. And it's going to stop you at Grub. So this menu right here is Grub. Looks nice. I think it's of the three that we're running, it's the only one that actually looks nice. But notice down here at the bottom where it says C, on the bottom left, C command line. You're going to want to click that or hit the C key. And that's going to drop you down to the Grub menu or the Grub command line. The idea with this is we're not going to go too far with this. What I really want you to do is find out the way that Grub looks at your system. It verified that it sees all of the disks. One of the things that I have that I've run into is the master boot record on the disk is still able to be read, but none of the data is able to be read. So the first thing that you might want to do in Grub is identify all of the things that show up. So let's read this and talk about what it means. So right here, HD0. That is referring to the first hard disk on your system, HD0. And when you're counting in computerese, that always starts with 0. So HD0, first hard disk. Then there are 3 other options that also include HD0. So HD0, comma, GPT3, GPT2, and GPT-1. So what I can learn from this is that there's one disk on the system because there's no HD1, and HD0 has 3 partitions, GPT-1, GPT-2, and GPT-3. So if you've ever added a disk or created a new partition on a Windows machine, I guess it's really when you add a new disk. It asks you, do you want to initialize the disk? And it'll ask you a question. Do you want to use master boot record or GUID partition? I forget what the T stands for. But anyway, do you want to use MBR or GPT? For larger disks, you want to use GPT, right? GPT can support larger than 2 terabyte partitions, but MBR cannot. So you run into a situation where you pretty much you're stuck. If you want to have big partitions, you got to use GPT. And for the most part, most operating systems just use GPT by default, as you can see. We will see though. I think both Ubuntu and CentOS use MBR, which will show up as MS DOS in Grub. So anyway, GPT 1, 2, and 3. That's the idea. Now what we want to do, now that we've identified what's going on here, 3 partitions, 1 disk, we can look inside of each of these partitions. Now, Grub is not smart. As I mentioned before, Grub tries to be as small as it possibly can. So there's no tab completion here, really. You can try, but it'll just yell at you. Anyway, so we can do GPT-1 and / like that. It does have to contain the parenthesis, and there can't be a space here. It's got to be just about perfect, right? And you need that trailing / there to say, I want to see what's inside of that partition rather than just partition information. But, as said, Grub is not smart. It doesn't do well with partitions that it doesn't know exactly everything about. So hit the up arrow key, and you won't have to type it all again. And you can arrow over and go to GPT-2. There we go. That's some stuff. And let's look in GPT-3. I think it's going to give us the same as GPT-1. Yeah, unknown. So GPT-2 is the one that we've now identified that has junk in it. So that's where we're going to focus. So use the up arrow key to get back to GPT-2. And then you can look inside of another directory. Boot is the one that I have mentioned here, and it's where you'll find all the Grub stuff. So look inside of there, and bingo. You find VM Linux or Linux. This is how you can identify the kernel. So VM Linux is really just this is the file name for the kernel. And the following numbers, 5318 in this case, that's the kernel version. So if you look a little further, you'll see right here, Grub2. If there's any entry, and you know they're a different entry because there's a space in between them, if there's any entry that has a trailing /, you know that's a directory. So, right, if you go down here, Simverse 5318 still has that same version number, whatever, blah, 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 but it doesn't have a trailing /. That is a file. VM Linux, again, no trailing /, that's a file. initRD, file, boot readme, a file. So the only directory inside of here is this grub2 directory. So just for fun, you don't need to do this in the lab. We can look inside this grub2 and see that's where our grub.cfg is. So when you want grub to boot, this is the file that it looks at to do so. All right. So that's really what I need you to do in this lab. I'm going to show you real quick CentOS and Ubuntu because sometimes they can be different. I want to show you the MS-DOS thing as well before I let you go. But that's pretty much it. So as for screenshots, I want you to show me a partition list. So let's see. Yep, start with the ls command. So when you do that, you'll see all these partitions. Take a screenshot of that. And then when you identify the kernel, so in our case that was lshdo gpt2 /boot / and we saw this, you want to select or you want to choose the one with the highest version number. Grub will always get updated with the one that has the highest version number. So if you've done updates on these systems, which we should have in that first lab, you will probably have two. You'll have the 5318 that was originally installed, and you'll have one that is a higher version number. That's the one I'm looking for. So highlight it, circle it, whatever you want to do. Doesn't matter to me so long as you identify it somehow. If you take the screenshot, just right under the screenshot, you can just write the file name down there too. Does not matter to me how you identify it. Just identify it somehow. Let me know that you know what it is that that we're talking about. We should be good. And then after that, reboot. Oh, and there's a typo here. There needs to be a slash after that boot. So I will update that as well. So reboot. And that will get us to, fatal keyboard error. Well, all right. So in that case, so the cool thing about just being in Grub is that if you do a hard reset or something like that, it won't affect the system. You get that recommendation all the time, right? Don't just hard reboot or plug out, unplug the power from your system or something like that. When you're in Grub, the system is not loaded, so you don't run the risk of doing any of that. So anyway, notice loading Linux, and it had that same version number that we saw in Grub. All right, and for that, I really just needed to prove to myself that I didn't blow it up. That what I'm saying is true. All right, so and we'll shut this guy down, and we'll move on to CentOS. And CentOS is the same way. It'll drop you into the Grub bootloader selection screen right here, and you can hit the C key again to get that same command line. You can do ls again to get that list, and as I expected, MS-DOS. So be aware. So remember how we do this, HD0, MS-DOS. I'm gonna try number 1 first. Hey, look at that, I got lucky. That's where all the stuff is. Now here's the deal. With CentOS and Ubuntu, they do not put these kernels in the boot directory. It's just right in MS-DOS 1 here. So be aware, you don't need the boot stuff after this. Just an ls of that partition and the trailing slash will give you all the information that you need. You can find your kernel here. If you want, you can go into grub2 to find the configuration file if you need. But that's about it, right? So find your kernel there. We should be good. That's pretty much all I need, right? Give me a screenshot of your partition list and give me a screenshot of a circled whatever the latest kernel is. Yeah, that's what reboot should have done. Should have taken you here and it'll boot the rest of the way, but I'm gonna stop it so we don't waste any time. And then lastly, Ubuntu. Now this one's the tricky one. CentOS and OpenSUSE drop you at that Grub screen to where you have plenty of time to hit the C key and get where you need to go and all that. Ubuntu does not. Ubuntu is very let's boot as fast as we can. So their Grub timer, the time that you get on that screen is set to 0, as in it don't ask you. So when you start it up, watch for the VirtualBox screen, and once it starts fading away, hit the escape key. You might have to do this a couple different times, but if you catch it before it boots, you can just machine, reset. Here, let's do that now, actually. Reset. VirtualBox, start hitting escape. There you go. And it drops you here. Otherwise, it would just have skipped this page. So make sure you're smacking that escape key as you come in here. And then, as before, C key. ls. Oh, okay, Ubuntu is GPT, not MS-DOS. So we'll do HD0, GPT2. Oops, forgot my trailing slash. That's what happens if you don't add that slash. There we go. Let's just see what's in GPT-1. Unknown. So GPT-2 is definitely where we want to be. And so Ubuntu. Oh, I said. You know what? I could have sworn. You know what? I know for a fact. I have another. I think it's because we've added in the desktop. The one I was running this on to make sure everything was good in the lab. had it just like CentOS, where you do ls of the partition and VM Linux and all that other stuff is in there, and you didn't have boot. So I think after we added, so y'all's will be like this. After we added the desktop environment, things got spread out a little bit. So in this case, you will need boot to see what's in there, and you can see right here, VM Linux, that identifies the kernel, and the latest one I've got is 4.15.0-130. Oh, wait. I take that back. Here it is, VM Linux 4.15.0-132. So this will be the most recent kernel, which means this is the kernel that we'll boot into as we come up. Let's see if we can catch that. So we'll do a reboot. See if I can catch it up here. It may show us real quick which kernel it's going to load. I missed it. But let's verify. Let me just log into it, and we'll verify. On CentOS, there was only one kernel. On OpenSUSE, it did tell us during that boot, but on Ubuntu, I just want to show you the kernel version. And we haven't really talked much about the kernel, but think of the kernel as the beating heart of Linux. It knows everything about all the hardware. And it is the middleman between the hardware and the software. So if your graphics card needs to draw something on the screen, that goes through the kernel. So the desktop environment is like, hey, I'm about to minimize this window, and it needs to fade away just like this and go into this little spot. And the desktop environment tells that to the kernel, and the kernel then tells that to the graphics card, and then the graphics card says, all right, boss, draws all that cool stuff on the screen. So we'll talk way more about the kernel later on. So uname R, same as before. Yep, it's not 130, it's 132. So make sure you're getting the biggest number in there. And if you want, there's nothing wrong with booting into the operating system and then just running this command to verify that the kernel that you selected on that screen is the right one. That way you know for sure that's the right kernel. So running this tells us what kernel we have loaded. All right. So that'll do it for all of that. So I just need y'all to just dive into Grub, learn a little bit about the system, see how Grub sees this stuff. Tell me a little bit about it. That's it. So give me that partition list and then circle the kernel version on each of the 3 operating systems. And that's what I need you to do. Take screenshots of each. As I mentioned before, PDF is best. Please submit via PDF. And by the way, just as a quick refresher, let's pretend this is the Kali one. Let's do Command-Shift-4. Oh, no. We'll take a screenshot of this. And then just don't forget, you can go to Drive, create yourself a new document. So back on your picture, do Control-C if you're on Windows, and Control-V, and that will paste that in there. And then you can say, this is the current running kernel or something like that, right? Something like that. That's the idea. All right. So that's all I need to show you. I'm sorry?
I just thought it was funny because last week you mentioned the movie Hackers, and I remember the scene in there where they get talking about they're going after the kernel.
Yep, exactly. If you can taint the kernel in some way, then yeah, a lot of times the tainting process gives you a lot more access than you would normally have.
Actually, one of my favorite movies back in the day.
Oh man, it's still one of my favorite movies. It's so corny. I love that movie.
It is.
Hackers is one of the best movies.
Me and my wife watch it, and we're like, could you imagine if it was really like that? System like that?
We'd have, if it were really like that, we'd have way more people in computing, I think, in general, just in IT. Looks cool. All right, I'll stop the recording here.